Today's lesson is going to be all about alcohols. Just to recap, we have done the alkane group with the single bonds, the alkene with the double, the alkyne with the triple. Today we're focusing on the alcohol family, and we did the haloalkanes last week. So we're moving on as we go through all of these organic families. Just a reminder that you can use the digital worksheet to type in as you go, or you can copy your own notes into a notebook. So an alcohol contains the functional group hydroxyl. And what hydroxyl means, it's just like the hydroxide group when we were naming compounds. So it consists of an OH group attached to, again, that R refers to that carbon chain. So I can have any number of carbons in my chain, and somewhere along that chain, I can have an OH group. And then the rest would be our usual hydrogen. It is important to note that there can be more than one OH group, but I'm not going to ask you to be able to name or draw anything with more than one hydroxyl group. To name these molecules, it's very similar to the ones that we've been doing so far. Number one is always find the longest chain. So once we find the longest chain, that creates the root to the name. And then we're going to number the chain, this time closest to the hydroxyl group. So find the OH, start numbering closest to that end. And that's going to, again, determine the position. So it's going to give us that number prefix for our OH group. And then how do we identify that we're dealing with an alcohol? We're looking for that OL at the end of the name. Just so if you can remember, alcohol ends in an OL. The name of alcohols will end in an OL as well. So when we're looking at a name of an organic compound, if I see an OL as the suffix at the end, I know that that means that that compound contains a hydroxyl group, an OH group, and I know it occurs wherever that number prefix tells me to put it. Okay, so that's sort of the three general rules for naming alcohols, very similar to what we've already. So if I take a look at these examples here, again, following my steps, longest chain here is 4. So the name for 4 carbons would have been butane. And then I look for the functional group, and in this case, the functional group I'm dealing with is the OH. So I know that that's the alcohol, so I need to put the OL ending on there. Since the rest of the chain is all single bonded carbons, I'm actually going to leave that AN, and I'm just going to take off the E and put the OL. So it's butanol, and then I have to look for the location of that OH group, and so I start numbering closest to the end with the OH, so that makes that carbon number 1, 2, 3, 4. So I have a 1-butanol. Okay, let's look at the next example to the right here. Again, counting my carbons, 3 carbons. So that would be prop. And it would be propane, but instead of propane, I'm going to put propane without the E. And I'm going to add the OL to the end because there's my hydroxyl group. So the only thing left to figure out is the number carbon. So I start numbering the chain closest to the end. So that's 1, 2, 3. So this is a 1-propanol. Okay, let's try the next one. Again, I'm looking at 3 carbons, so I know it's propanol because I've got the OH group. This time it's at carbon number 2. So it's 2-propanol. You may have also noticed that this can be called isopropyl alcohol. So that's actually the molecule that's in rubbing alcohol. So rubbing alcohol is isopropyl alcohol. So when you see that isopropyl, remember when we were naming hydrocarbons, that was the branch that had 3 carbons where it attached to the main chain like that. So that's kind of the same idea. So it's my 3-carbon chain and my hydroxide is attached to the middle carbon. Whereas if I look at that 3-carbon chain here, I've got the OH group attached right here. Okay, taking a look at the last one here. Again, I've got 4 carbons, so I know that that's butanol. And I'm looking at numbering my chain closest to the end. So it's going to be at carbon number 2. So I have 2 butanol, but I forgot the T, butanol. Okay, so our structures, as you can see, are very similar to our hydrocarbons. We've just replaced one of the hydrogens with an OH. And again, by no means are the only alcohols containing one hydroxyl group. There are many that have multiple hydroxyl groups. But again, to keep it simple for us, we're just going to deal with the ones that only have one of the hydroxyl groups on there. Okay, so let's talk about properties. Once I put in that OH group, that makes my molecule very polar. So that hydroxyl group is a very polar group, so I get that higher boiling point and melting point. Why do I have that higher boiling point and melting point? Because I have that hydrogen bonding. So this contains that OH group, so when I have an OH, remembering that that gives a partial positive charge to the hydrogen and negative charge to the oxygen, that's hanging off that carbon group, which also gets the positive. So that allows it to attract other molecules. So in doing so, it's creating strong attractions between the molecules, which takes more energy to spread them apart. So that's why I need the higher temperature to boil it and higher temperature to melt it, because those attractive forces are holding those molecules close together. Because it has those things going on, that allows it to be soluble in water, because water also has hydrogen bonding. And just like any other alkane and most organic compounds, it is combustible, so it will burn readily. An important facts and notes about alcohols: most are toxic and poisonous. So even the ones we drink are actually toxic, and you may have heard of people having alcohol poisoning. So our body doesn't like alcohol. Most of them are highly poisonous and toxic. Ethanol is the one that is the least, and so that's the one we find in alcoholic beverages. Rubbing alcohol, just like I said, is 2-propanol or isopropyl alcohol. So it's 3 carbons long. Antifreeze is also a very toxic alcohol with a sweet taste. So that's a problem for animals, right? Because if they find antifreeze on the ground, they will lick it up because it tastes really good. But it's actually ethylene glycol, which is another alcohol that's really toxic. Ethanol is produced from the breakdown of sugar with the help of yeast. So you've heard that as fermentation. So alcohol is produced from fermentation, breaking down the sugar and turning it into an alcohol. And just an important note, you can read lots of ingredients and hear about lots of different molecules in the organic chemistry world, and anything that ends with that OL is going to be an alcohol. So cholesterol is actually an alcohol. Glycerol is an alcohol. So just kind of making you a little bit more aware of where you find these alcohols in your everyday life. Maybe you might want to choose one of these compounds to do your project on. And for practice, I just have some practice that comes from your textbook. So you're just drawing some structures of alcohols and then learning to name the alcohols from a condensed structure. Okay, so good luck. Let me know if you've got any problems.